Okay, so today we're going to talk about parallel lines, equations of parallel lines. Parallel lines are lines that are in the same plane and never touch. Okay, like a plane is like the coordinate plane, the xy axis. Okay, think about parallel lines for me for a minute. When you have parallel lines, what do you notice about the slopes of parallel lines? What has to happen for the slopes?
Equal.
What are they?
Equal.
Well, he said it right before I called on you, but yeah, they're equal. Yes, they have to be the same. Slopes of parallel lines have to be the same. So when you're writing equations of parallel lines, their slopes are going to be the same. That's a property of parallel lines. They have to be, because if they don't have the same slope, think about it, they're going to intersect. Okay? So that's the main thing that you're going to learn today, is that parallel lines have the same slope. That's like key. That's the thing. Example 1. The first example, we're going to determine whether lines are parallel or not. And to do that, we're going to have the equations of two lines. And we're going to have to decide what their slopes are. And if they're the same, we can say they're parallel. If they're different, then they're not parallel. So if we're looking at the two equations, the first one is y equals negative 1/3 x plus 5. What is the slope of this equation? Negative 1/3. So we have m is negative 1/3 here. Now, here's the trouble in the second equation. Do we see what the slope is? We can't tell what the slope is, so we have to actually change this into slope-intercept form, because this isn't standard form, and you cannot get a slope from standard form. So you have to manipulate it, transform it, which I know you've done a lot of this in science. I think you have anyway. I carpool with some of your science teacher. Some of you guys' science teacher. Who's Hackett?
Nope.
Okay. 2x plus 6y equals 12. All right, so we need to get this into y equals mx plus b form. So that means the y is by itself. So we need to start manipulating this equation to where we get y by itself. Yes, we want to isolate this 6y term. We want to get it by itself right now. The y we want to get by itself, but for right now, we'll just get 6y by itself, and then we'll go from there. So we need to subtract 2x from both sides of this equation. So we bring down our 6y equals negative 2x plus 12. Because we couldn't combine 12 and negative 2x because they're not alike. So you have to just write them separately. Write the x term first, because in slope-intercept form, the x term comes first. It's not wrong if you do it the other way, but that's just how slope-intercept form is. Now we can concentrate on getting the y completely by itself. What do we do? Huh? Yeah, you want to get the y by itself. So what do we do with the 6? Divide. We divide. Because it's being multiplied by y, the opposite of multiply is divide. So we divide everything by 6. And we have to divide everything by 6. Whatever we do to one side, we got to do the other. Huh? How do you know?
Because if you divide 12 by 6, that would equal 2, and 2 and 5 are not equal. But
Oh, no, that's not the slope. That's the y.
Yeah,
Okay, all right. So we're going to cancel out our 6's. So we get y equals, and then negative 2 over 6, what does that reduce to? Negative 1/3 x plus 2. So the slope on this line, we can now tell what the slope is. The slope is negative 1/3. Are both slopes negative 1/3? Yes, so we say that they are parallel. All right, so the biggest thing on these problems is you're going to have to transform one of the equations to get to where it's in slope-intercept form. You always want to solve for y. Okay. All right, we got another one just like this. Letter B. All right, we got two equations here. We want to know if they're parallel. The one on the left, we're going to have to manipulate a little bit because we can't tell right now. The one on the right, can we see what the slope is? Yeah, the slope on the one on the right is 3/4. So we got that one taken care of. So now we just need to transform the equation. Negative 6x plus 8y equals negative 24. We follow the exact same steps. We want to get the term with y by itself. We can't get y totally by itself yet, but we can at least get the term that contains y by itself. So right now we can add 6x to both sides. So we get 8y equals, write your x term first. Okay, so we've gotten 8y by itself. Now let's get y by itself. So we divide everything by 8. So we cancel out these 8s, we get y equals. All right, what's 6 over 8 in fraction form, reduced fraction form? What is that? 3/4? Yep. So 3/4 x, 24 divided by 8, we get -3. So our slope then is also 3/4 on this one, so we can say yes, they're parallel. If they were different, we would have said no. Are there any questions on letter A or B? You're going to have to follow this process several times during the homework, okay? So you get a lot of practice with it. All right. Example 2. Example 2, we're going to write an equation of a line. All right, we're going to write an equation of a line. We did a lot of that already. But this time what we're going to do is we're going to write an equation of a line in point-slope form for a line that contains the point 5,1 and is parallel. Here's your key word. And is parallel to this line right here, to y equals 3/5 x minus 4. Now, in point-slope form, immediately, hopefully you guys are starting to know point-slope form. But if you don't, point-slope form is y minus y1 equals m parentheses x minus x1. There's your point-slope form. For point-slope form to write an equation, we need two things. What do you think those two things are? For point-slope form, what are the two things that we need? We need a slope and a point, right? Right? Think about it. Point-slope form. Don't we need a point and a slope? Okay, that's why it's called point-slope form. Okay, so we have a point. Here's the point. And this is x1 and y1. So now we already know we have an x1 and a y1. Now we need a slope. The only thing we know about this is that it is parallel to this equation right here. So we can get a slope from here, right? What would the slope of a line parallel to this one be? 3/5. So we're going to use m as our 3/5 as our m. Because we're writing the equation of a line parallel to this one. All right, so then it's a matter of just plugging in our x1, our y1, and our m. We just plug those three pieces of information in and we got it. So we got y minus y1 is 1 equals m, which we found is 3/5. X minus x1 is 5. So here is our equation in point-slope form. Does that make sense? Just pull the slope out of the equation they give you. Take the point, plug it in. Okay. So that's part A. That answers part A, because this is point-slope form. Now part B wants us to write it into slope-intercept form. So we're going to have to practice going from here to slope-intercept. So what you need to do is rewrite that down on letter B. So rewrite that equation down here on letter B. Let's see, it was y minus 1 equals 3/5 x minus 5, I believe. Yes, okay. So we need to take the steps to getting this into y-intercept or slope-intercept form, which is y equals mx plus b. So we need to get y by itself. But before we can do that, we have some parentheses to take care of. So the first thing you have to do is do the distributive property. So we're going to distribute 3/5 to the x and to the -5. So we get y minus 1 equals 3/5 times x is 3/5 x. 3/5 times -5. Anyone know what that is? No. What is 3/5 of 5? It's -3. And the way to look at it is if you put the 5 over 1, you got a 5 in the denominator here, a 5 in the numerator there, they cancel. So you get -3. All right, and then, now that we did that, we can get y by itself by adding 1 to both sides. That cancels, we get y equals 3/5 x. -3 plus 1, we get -2. So now we have that equation in slope-intercept form. Any questions on that process? 2 steps. Do distributive property, then isolate y. Get y by itself. Then we got one more. We're going to write it in standard form next. We're going to do like what we did over there on 24. All right, so rewrite that equation. The y equals 3/5 x plus, was it minus 2 or plus 2?
Minus.
Okay, so rewrite that. Y equals 3/5 x minus 2. So now we want to go from slope-intercept to standard. Standard form has no fractions, so we have to clear the fraction. How do we get rid of that 5? Multiply by 5. Multiply this whole thing by 5. Okay, so we have 5y equals, our 5's cancel here. We get 3x, and then negative 2 times 5, we get negative 10. Okay, we're almost there. I've got standard form written over here. Ax plus by equals c. So the x and the y term are together on the left side of the equal sign. So that means we need to take this 3x and move it. So it's a positive 3x, so we're going to subtract 3x from both sides. We write the x term first, so it's negative 3x plus 5y equals negative 10. And now we have it in standard form. So it's the same equation written 3 different forms. Are there any questions on that process? The key thing that you need to take from right now is that slopes of parallel lines are equal. That's the key piece that you need to take out of it.